All right, welcome back. And now we're here to talk about the 5.4 solving radical equations and inequalities, day 2. So notice some things that are in this that are really just extensions of what we've been doing, particularly isolate the power. In this case, we're isolating the fractional exponent, and then raise each side to the reciprocal of the rational exponent. Okay, so let's first talk about um, isolating that radical, or isolating that fractional power. So to do that on this first example, on example 5, would be to subtract 2. So we'll have 2x raised to the 3/4 power equals 8. Okay, because we subtracted 2 from both sides. All right. Now, if we want this to become just 2x to the first power, then we want to raise both sides to the 3/4 power. See, if we do this and put a 3/4, or I'm sorry, 4/3 out here and a 4/3 here, 3/4 times 4/3, those are reciprocals of each other. And when you multiply those exponents, which you would do because you have one exponent on the outside and one on the inside, then that would become just 2x to the first, which is what we wanted to do. Okay, then 8 to the 4/3. Now remember, the top number is a power, the bottom number is a root. So the cube root of 8 is 2. Okay, and so this is going to become 2 to the 4th. Okay, because the cube root of 8 is 2, so it's 2 to the 4th, and that's 16. So now we have 2x equals 16, and we can divide by 2. X equals 8. And just like magic, we have a solution to what looked like a really nasty equation. Now let's try it on this one, this extra example. So we've got 3x raised to the 3/4 power minus 2 equals 25. So for that, we should add 2. So this will be 3x to the 3/4 power is equal to 27. Okay, and again, let's take that 3x to the 3/4 power. Let's raise that whole thing to the 4/3 power. Then when we multiply those two exponents, we'll have something to the first power. But we have to do whatever we do on the left side, we have to do on the right side. So this is to the 4/3 power also. So this part, 3/4 times 4/3, that equals 1. That's what we wanted. So 3x equals whatever 27 to the 4/3 power is. Now 27 to the 4/3 power, that's a cube root to the 4th power. So the cube root of 27 is 3. So this is 3 to the 4th. And 3 to the 4th is 81. And then all we have to do is divide by 3. And that's 27. All right. Okay, this is these next two are really similar. Especially, they're very similar in the terms of the original strategy. So let's see if I can get a little closer. See that a little better. All right, so these are just like a 1/2 power. A 1/2 power is just like a square root. So this could be x plus 30, the square root of x plus 30 equals x. And that's a radical that is by itself. We've isolated it, so we can square both sides. And the right side will become x squared. This side will become x plus 30. Now, that's a quadratic because we have x squared, and our strategy for those is always to get it equal to 0, because that is how we can use our either factoring or quadratic formula strategies. And so if we leave x squared on the right, we bring x over to the right, it'll be negative on that side. The 30 will be negative on that side. And now I think you can see where we would find some factors where we find a product of 30 and a sum of negative 1. 6 and 5 should work, negative 6 and positive 5. And 6, if those are the factors, then 6 and negative 5 would be a solution. I can't quite see that. Okay, now, of course, we should check these. And I think 6 plus 30 is 36. The square root of that is 6. So that one checks out. But negative 5, we can't do a square root and end up with negative 5. Okay, if we do the square root of something, we're not going to, not any real number, are we going to get negative 5. So this one doesn't work. So 6 is our only solution to that. Okay, this one over here, this extra example, is similar. This is just going to be square root of x plus 12 equals x, and we can use a similar strategy to what we just did over on the other one. And if we square both sides, it's easy on the left. It becomes x plus 12. This one becomes x squared, squaring both sides because the radical was already by itself. It's a quadratic. We want it equal to 0. To do that, we're going to need this to be negative x and negative 12 on the right-hand side. And I bet you can see some easy factors for 12 that would have a sum of negative 1. Looks like 4 and 3 will work with the 4 negative and the 3 positive. And with those factors, we would have to have 4 and negative 3 as our solutions. And again, once we check, this one, 4 plus 12 is 16. The square root of that is 4, which should be that. So that works, but negative 3, again, if you can't get a square root to come out negative, so there's no way that we can put a number in here that will result in getting negative 3 as the result over there. So you can't use negative 3. All right, let's turn the page, and we'll look at some inequalities. All right, notice that what it says in the text here is that you can do the same sort of things you do to solve any inequality, and you can take for instance, the square root of something, and that maintains the relationship of the inequality. So, for example, on this one we have 3 times the square root of x minus 1 less than or equal to 12, so we can treat this as if it were an equation, and that looks like it's being multiplied by 3, so in order to isolate the radical, we should divide by 3. That'll cross those out. That'll give us the square root of x minus 1 is less than or equal to 4. And if we take if we square both sides to undo the radical, we will have x minus 1 on this side. On this side we'll have 16. And if we add 1, that's 17. Now remember, if we're going to put that on a number line, we should just put 17 on there. And we're going to shade to the left. And we're going to fill in the circle because we had not just strictly less than, but also equal to. All right, on number, or this extra example over here, let's see, we have 3 times the root of x minus 4 less than or equal to 8. Undoing minus 4 means we should add 4, so 3 times the root of x is less than or equal to 12. Dividing by 3 gives us the root of x is less than or equal to 4. Squaring both sides gives us x less than or equal to 16. And then we're going to have 16 filled in circle, shaded to the left. Very similar to our prior example. There's the number line. All right, I'm going to stop there and then give you some coaching on these practice problems down below in another segment.